Hello, everybody. Welcome to the continuation of applying transformations to quadratic equations. This lesson, we're going to learn how to apply multiple transformations and making equations from a list of transformations. My computer is super slow today. Can we get this going? Okay, there we go. Okay, so our learning goal today is to create an equation in the form of y equals a times x minus h squared plus k from a list of multiple transformations on y equals x squared. Okay, so first of all, I just wanted to let you know that this form of the equation is called the vertex form of quadratics. And the reason why this is called vertex form, because if we pick out h and k, that gives us the coordinates of the vertex. And we're going to do some examples with this first before going on to the main part of the lesson. So what we have here are a bunch of equations in vertex form. So vertex form is this. And it wants us to state the transformations of these equations. So just like what we did last day, but this time we're going to have some with one transformation, and then we're going to get into some with multiple transformations. And then it wants us to say what the vertex is. So that means we're going to pull out h and k from each of these equations to say what the vertex is. Okay, so let's take a look at this first one, x squared minus 5. Well, that minus 5 is in the k spot, which is the vertical translation. So that means this is going to go down by 5. Or it's going to have a vertical translation of negative 5. This one here, the negative 5, or sorry, the 5 is in the h spot, and h is the horizontal movement. Now, because this is negative and this has a negative, that means it's going to go to the right by 5. Because remember, if I put a positive 5 in here, then it looks like a negative 5. So this is going to the right by 5. This one, another single transformation. Um, the x squared is being multiplied, and if you remember, that means we're going to have a vertical stretch. And we're going to have a vertical stretch of 3. And remember, that means our step pattern is going to be multiplied by 3 if we graph it, but we're not worrying about the graphs today. Now, the next 3 have multiple transformations. So this time we have an x plus 4, which means to make that happen, we had to put in a negative 4. So that means we've moved to the left by 4, and the 6 is where the k is, so we've moved up by 6. So up by 6, left by 4. This one here, we have a 1/2 in front. So that means, remember, if it's between negative 1 and 1, so if it's a fraction or a decimal, it's a horizontal, sorry, a vertical compression. Then we have this 1 in the h spot. To make it a plus sign, that must be negative 1. So that means it's gone to the left by 1. So vertical compression by half and left by 1 for that one. This last one has a negative sign in front, which means it's reflected over the x-axis. It has a 2 in the A position, which means it's vertically stretched by 2. We have a 3 in the H position, so that means it's moved to the right by 3, and a 7 in the K position, which means it's gone up by 7. And that is the maximum number of transformations you can have of a quadratic equation. So now let's take a look at the vertex. Remember, for the vertex, we just need to pull out what our h is and what our k is and put it in the form bracket h comma k, and that gives us the coordinate of the vertex. So for the first one, notice how we don't have x minus something. So that means h is 0 and our k is negative 5. So our vertex is 0, negative 5. In the same way, but opposite, we have a 5 in for the H and nothing for K. So that means our vertex is 5 and 0. For this one, there's nothing in the H spot or for the K spot. So that much means it hasn't been moved vertically or horizontally, which is true. We've only stretched it. So that means our vertex is still at 0, 0. By the way, you could always check these by putting these into Desmos. Okay, the next one. Well, we have a 4 in the place of the H, but don't forget, because it's a positive 4, to make it positive, I had to put in a negative 4. So my H is negative and my K is 6. So the vertex is negative 4 and 6. For this one, again, we have a positive number, so my H has to be negative 1, and we don't have a K, so that much means it's 0. And then my last one, the 3 is in the place of H, so my H is 3, and my K is 7. So my vertex is 3 and 7. So that's what you need to do if you see a question like that. So that is, given an equation, can you find the transformation and state the vertex? Now we're going to go backwards. Can you write the equation in this form using the transformations? So we've got a vertical translation of 3. So remember, vertical translation, that's K. So K is going to be 3. Vertical stretch is 4. Vertical stretch is A. So A is going to be 4. And horizontal translation of negative 1. So that's H. So if I put negative 1 here, it's going to be minus negative 1. So it's going to be plus 1. So the answer is y equals 4 times x plus 1 squared plus 3. Okay, for B, it's opening down, which means A is negative. But it doesn't say there's a stretch, so we're just going to have a negative there. And the vertex is negative 4, negative 3. So remember, our vertex is H, comma K. So we're going to put in negative 4 for H. So minus negative 4 will be positive 4, and then negative 3 for K. So our answer is y equals negative times x plus 4 squared minus 3. You can put a negative 1 here if you want to, but remember to be more specific in math, can just have a negative there. Okay, this one, we have a vertical stretch of 3, so that means our A is going to be 3, and our vertex is 7 and 1. So we're just going to plop in 7 for H and 1 for K. So our equation is y equals 3 times x minus 7 all squared plus 1. And the last one, we're told what the vertex is, so we can put negative 1 in for H. So remember, negative 1, and it's subtracting, so it's going to become positive 1, and then our K is 7, and then it's a reflection, so that means it's going to be a negative in the front. So y equals negative x plus 1 squared plus 7. And that's it for today's lesson. So we're just taking what we learned from last lesson, which is relatively long, and just applying multiple transformations at the same time. And we were able to have the equation and then name the transformations and then go the other way. Given the transformations, can we make the equations? Okay, so for practice, I've made up a short applying multiple transformations practice page. It's posted on Brightspace. The answers are provided at the bottom. And then you can go ahead and try quiz 5.4. It's just a matching quiz where you're given transformations and you have to match it to the correct equation. So that is it for this lesson. We only have one more lesson left, I believe. No, two more lessons, sorry. um, Graphing with transformations and then applications will be the last two lessons. So see you next time. Bye-bye.